I wanted to do a quick overview of, again, terminology that you may see on the exam, concepts that you've worked with, but I want to make sure you've got the terminology for these. When we talk about object-oriented programming, the characteristics of a language that make it object-oriented are things like encapsulation, inheritance, polymorphism, and abstraction. So if a language incorporates those things, we say it is object-oriented. The most fundamental concept is abstraction. And abstraction is when we create well-defined objects and we define the instance variables within the objects. We don't let the user get at the instance variables directly. We protect them with methods. And so everything that pertains, in this example they're using car. So everything that pertains to a car is in the car class. It's not in 2 or 3 different classes spread around unintentionally because somebody was programming haphazardly. We sit down, we think about what a car object is, we think of all of its characteristics, its state, its behavior, its methods, and we put all of those into one file, and we hide from the user some of the details. The user just needs to know how to create a car, the different things they can set on a car, and so on. So car becomes one single object, and it might actually have other objects in it. It might be an engine class, and we might have an engine object created in car. But the idea is that we have well-defined objects and we have hierarchical relationships where appropriate through inheritance. We have has-a relationships where appropriate through composition, which I touched in an earlier recording, and that's where I have one class that has in it an object of another class type. So that is one thing that is characteristic of object-oriented languages, is abstraction. And the other things are encapsulation, inheritance, and polymorphism. Now, I did several good recordings on inheritance, and at this point you should have a handle on that. You recognize it with the keywords extends. We say that that is an is-a relationship. Child is a parent. So border collie is a dog, dog is a mammal. That's a hierarchical inheritance where dog is a superclass and the parent, mammal is a superclass and the parent of dog, and dog is the superclass or parent of border collie. So inheritance you should have a handle on now. When we talk about polymorphism, I'm going to jump to that one really quickly. There are 2 types of polymorphism. We've seen overloading. We've talked about overloading. There's also overriding, which comes into play with inheritance, and I want to talk about that a little bit more. We can process things differently. We can have one method that acts differently, and you and I know that that's because there's really several versions of that method with slightly different signatures. But to the user who's using your code and doesn't see the implementation, they just know that, hey, if it's a credit card and I want to know the how the interest I'm accruing for the month, I pass it my balance and interest rate. If it's a savings account that's compounded quarterly, unlike maybe credit card that's compounded daily interest, I'd still pass the same information. I always get the right answer back. You and I know this will be maybe two slightly different methods, but to the user, they just know, hey, I call the calc interest method, and depending on what I'm doing, I send it different pieces of information and I get my answer back. So polymorphism is that concept. Something can behave differently based on what's being passed to it. It can have multiple implementations and so on. So let's talk a little more about overloading versus overriding. And I want to throw out the idea that there's actually static polymorphism and dynamic polymorphism, and we'll talk about that more in a minute. It just has a little bit difference of performance. So static polymorphism refers to writing code in such a way, which is overloading, that everything that's required for the compiler to understand that we have these different methods with same name and different implementations, that all happens anytime you compile, not necessarily run. But when you save and it compiles, everything that the Java virtual machine needs to do to understand that I have several different method A's, but they have slightly different implementations, all of that is put down into machine code at compile time. Not when you're running it necessarily, but when you're saving it, for example. And so overloading is what we call static polymorphism. Everything that needs to happen for the compiler to understand that you're going to use the same method name with different signatures, different parameters, happens at compile time. And so here's an example of overloading, which we've talked about before. One method with, well, sorry, three methods with the same name. So we have one name, method A, and we tell them apart by the signature, that we have different types and numbers of parameter. One takes a single int, one takes a single double, and one takes two integers. So the compiler can tell them apart when somebody invokes one of these methods based on how many things are passed to it and the data type of whatever is passed to it. And it knows which one of these to choose based on that. All of that understanding happens at compile time, which could be different than runtime. Usually it's when you save, right, is when it compiles. We call that static polymorphism. That has better performance than dynamic polymorphism. Think about it. Everything's already taken care of when you save it. Then when you go to run it, the compiler doesn't have to like scratch its head and try to figure things out. It's already figured it out. It's just waiting for you to run the code. Now we have overriding, which is dynamic polymorphism. Whatever the compiler needs when you're dealing with overriding, whatever it needs to understand, it happens as the code is running. So it's not only like trying to process through all the lines of code, now it's got to do a little bit of thinking, so the performance is not quite as good here. But let's see, we're talking about overriding. Let me make sure I'm saying the right term, overriding here. And that is where, when I have a situation with inheritance, notice I've got a parent class X. Sorry, I must have clicked on an ad. So I've got a parent class X, I have a child Y. I know this is the child because it extends X. So extends, child extends parent. Y is a X, for example, in the UML terminology. And notice here I have a method A in the parent, I have a method A in the child, and the output of these is different. If I wanted to invoke the parent method A, I would do that in main just as if method A was in class Y. And I wouldn't have to type it in if I wanted to use the exact hello, I'm method A of class X output, right? But if I decide that I want to use the same name, notice it's public void just like in the parent, but I want different output. I might have a different formula. Here I want to print something out different. I can override it by just doing it as if it wasn't even in the parent, right? So I'm going to type my own code here. When I create an object of type X and I do method A, I'm going to get hello, I'm a method A of class X. When I create this other object, which is of type Y, object 2, and I invoke that method A, I'm going to get hello, I'm a method A of class Y. Okay? So if there's a method in the parent and I want to use the same name, basically the same signature, these are identical as far as public void method A, but I want different calculations or different output, I am allowed to do that in the child. That's called overriding. But the compiler does not understand that there are these two methods and that when it's one object type it uses this one, when it's the other object type it uses that one. That understanding doesn't happen until runtime. So now you can see why that's going to be a little slower. Performance is not going to be quite as good as with the other situation we talked about. Overloading, This is overriding. So it not only has to sort of figure that out at runtime, then it has to figure out, okay, which object am I? Okay, go to this one. Oh, for this other one, go to that one. So the performance is a little slower. That's called dynamic polymorphism. And that's the difference. So if I'm in inheritance and I want to use the same method that's in my parent, but I want to implement it differently with different code, I call that overriding. That is dynamic polymorphism. If I want to just have in the same class multiple methods with the same name but slightly different signatures, that happens. That is static polymorphism. The understanding the compiler needs happens at compile time, and performance is a little bit better. So those are a couple of concepts with polymorphism I wanted to make sure you understood. And then finally we have encapsulation, the idea that if we are building an object, we put everything related to that object in it, and we don't put things that don't relate to that object in it. So if I'm creating a class called teacher, and I know that teachers have names and dates of birth and phone numbers, but for some reason in my program I want to track I don't know, parent information, because I'm tracking that for students. I don't want to put parent information in my teacher when that's not relevant. I want to put that in my student. Not the best example. But the idea is when you sit down to design a class, you think before you code. You put all the instance variables, the methods, so the state and behavior, and pertain to that object in it. You don't accidentally, or because you're lazy, put something that should be in another class. For example, I don't feel like creating a student class, so I'm going to jam all the stuff for student and teacher in one class. And I'm just going to call it person. Well, the better way to do that is to have inheritance with person having all the concepts they share, and then student and teacher being children of that human class. But they each have their distinct characteristics, and I don't mix and match. I don't put GPA in the teacher class. I put that in the student class, for example. Those are some terms I just want to make sure that you refreshed your memory on before the AP exam.